Dear students, let's start with the topic magnetic effect of the current. We all are very familiar with the word magnet. What is magnet? Magnet जिसके चारों तरफ एक मैग्नेटिक फील्ड डेवलप हो, यानी बचपन से ही हमें ये पता है कि अगर कोई चीज मैग्नेट है तो उसके पास में जब हम किसी आयरन को लेके जाएंगे, लोहे की चीजों को लेके जाएंगे तो इट विल बी अट्रैक्टेड, और अगर हम किसी मैग्नेट को लेकर जाएंगे तो इधर इट विल बी अट्रैक्टेड और रिपेल्ड। इसी प्रॉपर्टी को हमें इलेक्ट्रिसिटी के थ्रू समझना है, एंड दैट्स द जिस्ट ऑफ द चैप्टर. सो व्हाट इज द मैग्नेटिक बिहेवियर, या हु वाज द फर्स्ट पर्सन जिसने बताया कि जब हम किसी कंडक्टर के थ्रू इलेक्ट्रिसिटी को पास करेंगे then it will behave as a magnet, and that property, that correlation is called as electromagnetism. That means कि when we pass electricity through a conductor, it will show some magnetic property, it will have some magnetic field around it, and that is called as the electromagnetism. Oersted ने सबसे पहली बार इलेक्ट्रिसिटी को एक सर्किट में भेजा और इसके बगल में एक उन्होंने मैग्नेटिक निडल को रखा. जब इस सर्किट के थ्रू इलेक्ट्रिसिटी को इन्होंने पास किया तो दिस कंडक्टर हैज सम मैग्नेटिक बिहेवियर, यानी ये जो मैग्नेटिक निडल है इट शोड सम डिफ्लेक्शन. इसमें इसमें इसके निडल्स में कुछ डिफ्लेक्शन हुए, एंड दैट शोड दैट कि व्हेन इलेक्ट्रिसिटी passes through a conductor, a magnetic field develops around it. Okay, so this is the activity simply showing the generation of the magnetic field lines through the circuit, and that was proved by keeping a magnetic needle near it. Now the next question comes कि what would be the direction of the magnetic field lines अगर मैंने इलेक्ट्रिसिटी के डायरेक्शन को चेंज किया. For example, in both the conditions, in both the cases, I am giving the electricity through the circuit, but the difference is in A diagram it is in upward direction, and in B diagram it is in downward direction. So if we are providing the electricity in upward direction, the magnetic needle is showing the deflection in the northeast direction, and if I have reversed the direction of the current, it is showing the deflection in the northwest direction. That means by changing the direction of the current, the direction of the magnetic field lines also gets reversed. Then the next question comes, what are the properties of the magnetic field lines by different types of magnets? Like we have different types of different shapes of magnet. For example, for the next question comes, what is the type of the magnetic field lines by different types of conductors carrying current? For example, if I have passed the electricity through a straight wire, then what is the direction of the magnetic field lines, or what is the pattern of the magnetic field lines? And if I have passed it through a circular coil, then what is the magnetic field lines pattern? Although the basic properties of the magnetic field lines are same, that is they are in a closed loops, they will never intersect each other, and they are in a very closed crowded position near the poles. All these properties will be common for all types of magnets or the current carrying conductors, but the pattern will vary. For example, if the question comes, you show by an activity the pattern of the magnetic field lines by a straight wire. जैसे यहाँ पे XY is the straight wire, this XY is the straight wire, और इस straight wire से मैंने इलेक्ट्रिसिटी को पास किया. ठीक है, तो किस तरह के मैग्नेटिक फील्ड लाइंस डेवलप होंगे? Here I have used a cardboard. ये जो येलो कलर रेक्टेंगुलर स्लैब से दिख रहा है, दिस इज अ कार्डबोर्ड, और मैंने इस कार्डबोर्ड के बीच में होल किया और इस स्ट्रेट वायर को इसमें फिक्स किया. ठीक है, जब मैंने इसमें इलेक्ट्रिसिटी प्रोवाइड किया तो देयर इज द जनरेशन ऑफ द मैग्नेटिक फील्ड अराउंड द वायर. मगर इसे प्रूव कैसे करेंगे? फॉर दैट on this cardboard, I will sprinkle some iron fillings or iron powder. Then this iron powder will arrange according to the field lines, like they are in the concentric rings. So just look at this diagram. They will be arranged like a concentric rings around the conductor. This is the conductor. Okay. So the pattern of the arrangement of these iron fillings will show the pattern of the magnetic field lines by the straight wire carrying current. Okay. And in the next diagram, I have just reversed the direction. Here the direction is downward. Here the direction is upward. Okay. So if I have changed the direction of the current, the pattern of the magnetic field lines has also changed. Like here it is anti-clockwise. It is anti-clockwise, and here it is clockwise. So we can also understand this by changing the direction of the current in the conductor, the magnetic field lines also changes. Okay. Now the next question comes, what decide the direction of the current and the magnetic field lines in a conductor? Or question arises, how will we find out the direction of the magnetic field lines when current passes through a conductor? And that is given by the Maxwell screw rule or right hand thumb rule, or Ampere's swimming rule. All these will decide the direction of the magnetic field if current is passing through a conductor. For right hand thumb rule, if we consider the right hand, the direction of the thumb to the direction of the current, the direction of the folding of the fingers will decide the direction of the magnetic field. Okay. For example, and this is the statement, imagine holding a current carrying straight conductor in your right hand such that the thumb points along the direction of the current, then the fingers of the hand will wrap around the conductor in the direction of the field lines of the magnetic field. So the question comes, what happens if I have considered that current is flowing in upward direction? So the fingers are folded inwards in anti-clockwise direction. Okay. And when the current is moving down in downward direction, the current is flowing in the clockwise direction. So according to the direction of the thumb will decide the direction of the magnetic field lines through a conductor. One more thing, sometimes in a question, there is written ki flow of electrons or flow of protons. In that case, just remember that the direction of the flow of electrons will be the reverse or in the opposite to the direction of the current. So the direction of the electrons is taken in opposite to the direction of the current, and the direction of the proton is considered to be the direction of the current. Okay. Then next, it arises that what decides the strength of the magnetic field lines through a conductor, और we can say कि किस तरह से हम किसी कंडक्टर में मैग्नेटिक फील्ड स्ट्रेंथ को बढ़ा सकते हैं. बट नेचुरल, जब मैंने इलेक्ट्रिसिटी को कंडक्टर, द वैल्यू ऑफ इलेक्ट्रिसिटी इज इंक्रीज, द फील्ड स्ट्रेंथ विल इंक्रीज, एंड मैंने किसी कंडक्टर से जितने डिस्टेंस को दूर किया, द मैग्नेटिक strength will decrease. So the field strength is directly related with the amount of the current through the conductor and inversely related with the distance from the conductor. The more the distance, lesser will the field strength. The near the object to the conductor, more will be the field strength. What would be the magnetic field lines pattern when current is passed through a circular coil? और जब अभी मैंने जितनी भी बातें कही, दैट वाज फॉर द स्ट्रेट वायर. ओके. अब मैंने उस स्ट्रेट वायर को मैंने थोड़ा सर्कल सा बना दिया इन अ सर्कुलर लूप. अब जो मैग्नेटिक फील्ड लाइंस होंगे उनका पैटर्न क्या होगा? एंड दिस इज डिसाइडेड बाय, अगेन we'll do the same activity. If the question asks what would be the magnetic field lines, or show by an activity the magnetic field lines through a circular coil, then you in the same way जैसे तुमने स्ट्रेट वायर के लिए किया वैसे यहाँ पे भी उस एक्टिविटी को करोगे. मतलब तुमने उस सर्कुलर वायर को एक कार्डबोर्ड में ऐसे फिक्स किया, ठीक है, और अगेन आयरन फिलिंग को इसके ऊपर स्प्रिंकल किया, एंड हाउ द मैग्नेटिक फील्ड लाइंस, the iron fillings will be arranged in such a way. Okay, so next is, what will decide the amount of the field strength by this circular wire? Again, जितना ज्यादा इलेक्ट्रिसिटी देंगे फील्ड स्ट्रेंथ उतना ज्यादा होगा, मैग्नेटिक फील्ड लाइंस उतने ज्यादा बनेंगे, उतने वो क्लोजर होंगे। एंड द नेक्स्ट इज, जितना पास हम इस सर्कुलर कॉइल्स के पास में अगर हम किसी ऑब्जेक्ट को रखेंगे तो उस पे मैग्नेटिक फील्ड ज्यादा होगा, ठीक है, रादर देन अगर हमने दूर रखा है। किसी मैग्नेट के जितने पास में रखोगे किसी आयरन सब्सटेंसेस को, वो उतने ज्यादा उस पर फोर्स अप्लाई होगा, और अगर तुमने आयरन को दूसरी जगह रखा है देन द मैग्नेटिक फील्ड स्ट्रेंथ विल डिक्रीज। इट इज फॉलोड एवरीवेयर। ओके, समझना है व्हाट इज सोलेनॉइड, क्योंकि जैसे अगर हमें पता हो गया कि वी कैन चेंज द शेप ऑफ द कंडक्टर, सो सर्कुलर कॉइल अगर हमने समझ लिया कि व्हेन वी आर पासिंग इलेक्ट्रिसिटी थ्रू द सर्कुलर कॉइल, और अगर मैंने उसके नंबर ऑफ टर्न्स को बढ़ा दिया and it is wrapped around some cylindrical structure, then this structure is called as solenoid. That is, we can just define the solenoid as it is a coil of large number of turns of insulated copper wire wrapped closely in the shape of a cylinder. It's a 2-marker question. What is solenoid? How it is made? Okay, so just you have to write it's a large number of turns of insulated copper wire wrapped closely in the shape of a cylinder. Okay, and the next question comes, what decides the amount of the what decides the magnetic behavior of the solenoid? Yeah, how the magnetic field lines are decided inside the solenoid. So if we increase the number of turns, if we increase the number of the turns, the strength of the magnetic field inside the solenoid will increase. So we have the ability to change the value of magnetic field strength in the solenoid, and that's why it is very much used for different purposes, and that's the practical application of the solenoid. The pattern of the magnetic field lines inside the solenoid will be decided by the clock face rule, and since it is a number of many circular coils around a circular cylindrical structure, so it will behave as a bar magnet. So in a bar magnet, we have a north pole and a south pole. किसी भी मैग्नेट में एक नॉर्थ पोल होता है, एक साउथ पोल होता है। तो अगर ये पूरे सोलेनॉइड को मैंने एक बार मैग्नेट की तरह कंसीडर किया, तो कौन सा पोल हमारा नॉर्थ पोल होगा और कौन सा हमारा साउथ पोल होगा, ये कैसे डिसाइड करेंगे? It is decided by the clock face rule. The direction of the current, if it is clockwise, then that is the south pole. If it is anti-clockwise, it will be the north pole. And this is called as the clock face rule. Okay. Then how we will increase the field strength of the solenoid? In solenoid, the magnetic field strength is changed by the amount of the current flowing through it. ये तो सारे, चाहे वो स्ट्रेट वायर में हो, चाहे वो सर्कुलर वायर में हो, चाहे वो सोलेनॉइड में हो, if we increase the current in the solenoid, the field strength will increase. Again, क्योंकि सोलेनॉइड में बहुत सारे कॉइल के टर्न्स हैं. Okay, so if we are increasing the number of turns, the field strength will also increase. And if I have used the rod of soft iron or steel, then again the field strength will increase. Due to some particular nature about the solenoid, it is mainly used in electromagnet. Electromagnet is simply if you are passing the electricity through a conductor, it will behave as a magnet. And this is the electromagnet. This property is electromagnetism. Okay. So if I am using a iron core, and then with the in terms of solenoid, I am using it as a magnet, then it is called as electromagnet. Or we can say that an electromagnet is magnetized on passing current through a solenoid and easily demagnetized when we are switching off the current. Okay, so where we are using the it as an electromagnet, so electromagnet is used in motors, it is used in electric bells, it is used in MRI machines, it is used in magnetic locks. So it has varied applications in our day-to-day life. Okay. So these are the practical applications of magnetic effect of the current.